Today we're going to cover section 7.1, Ratios and Proportions. By the end of this lesson, we'll be able to write ratios and solve proportions. First, we need some vocabulary. A ratio is a comparison of two quantities by division. So here we have the three different ways we can format a ratio with the two numbers a and b, as long as b is not 0. We have fraction format, a to b here. We have a second format, a colon b, and then we have it written in English, a to b. Generally speaking, ratios are written in the same units and simplified. So if we want to write a ratio, we have a 15-inch bonsai bald cypress tree, which is a small version of a full-size tree. There's a bald cypress tree called the Senator, which stands at the Florida State Capitol. That's approximately 118 feet tall. So if we wanted to write the ratio of the height of the bonsai tree to the height of the Senator, in this case I'll use the fractional format. So here I'm going to write that the bonsai tree is going to be related to the Senator. Once we have that, I'll format it so that we have the numbers. So here we have 15 inches for the bonsai tree, and we have 118 feet for the Senator. Here we have the issue where these two numbers are written in different units. Generally speaking, the easiest way to deal with this situation is to convert it to both the same units, and usually we go to the smaller of the two. In this case, since inches is smaller, I'll convert the 118 feet into inches. So the bonsai is still 15 inches. And if we convert 118 feet into inches, it is 1,416. Now that the two numbers are in the same units, we need to reduce the fraction. One of our numbers is odd, the other is even, so they're not both divisible by 2. So let's check to see if they're both divisible by 3. 15 can certainly be written as 3 times 5. Since 1 plus 4 plus 1 plus 6 is 12, we know that 1,416 is also divisible by 3. So 3 goes into 14 4 times. There's 2 left over. Goes into 21 7 times. And 3 goes into 6 twice. So here we were able to cancel the 3's. Since 5 is a prime number and 472 is not divisible by 5, we know that the ratio of the height of the bonsai to the height of the Senator is 5 to 472. The second type of problem that we might run into is taking a known quantity and dividing it into a ratio. So here we have the measures of two supplementary angles, and they're in the ratio of 1 to 4. So we need to find the measure of the two angles. So first, an important fact that we've known for some time now, supplementary angles add up to 180 degrees. So we have two angles that add up to 180 degrees. We have one angle that has one part and another angle that has 4 parts. So in this case, I'm going to say 1 part of x plus 4 parts of x equals 180. So again, in this case, the 1 and the 4 come from the ratio. So if we combine like terms, we get 5x equals 180. 5 goes into 18 3 times. And 5 goes into the remaining 30 6 times. So in this case, one of the angles measures 36 degrees. To find the second angle, we have to have 4 times x. 4 times 6 is 24. 4 times 3 is 12, plus the remaining 2 from the earlier problem, we have 144. So in this case, the two angles are 36 and 144. Sometimes we want to compare more than just two numbers. In that case, we use an extended ratio. An extended ratio can compare 3 or more numbers. So we have an extended ratio, a to b to c, and we say that the ratio of the first two numbers is A to B, the ratio of the last two numbers is B to C, and the ratio of the first and last numbers is A to C. So occasionally we'll see problems like problem number 3. The lengths of the sides of a triangle are in the extended ratio 4 to 7 to 9. The perimeter of the triangle is 60 centimeters. What are the lengths of the sides? So very similar to what we just did, we have 4 parts make one side, we have 7 parts which make the second side, and we have 9 parts which make the final side. We know that if we add all of these together, we should get the perimeter, which is 60. Combining like terms on the left-hand side of this equation, we get 20x equals 60. Divide both sides of this equation by 20, we get x equals 3. So once we know what x is, we take x and we plug it into the 3 parts, and that'll give us the length of the sides. So in this case, we have 3 times 4, which gives us 12, 3 times 7, which is 21, and 3 times 9, which is 27. So in this case, the lengths of the 3 sides are 12, 21, and 27 centimeters. A good way to check this kind of problem is to take the numbers and make sure that they work the way we expect them to. So 12, 21, and 27, if we add them together, we expect to get 60. So we have 2 plus 1, which is 3, plus 7, which gives us 10. So 2, 4, 5, 6, and we do in fact get 60 when we add together 12, 21, and 27, which confirms that our answer is correct. So when we have an equation that states that 2 ratios are equal, we call that a proportion. In a proportion, the first and last numbers are called the extremes, and the middle 2 numbers are called the means. Oftentimes when we read this, we'll read this equation as 2 is to 3 as 4 is to 6. So we're probably fairly used to solving proportions. One of the things that we use to solve proportions is called the cross products property. It states that in a proportion, the product of the extremes equals the product of the means. So in this case, if we look at the symbols, it says if A over B equals C over D, and both B and D aren't 0, then A times D equals B times C. So an actual example from the previous slide, we have 2 over 3 equals 4 over 6. To confirm that that's true, we could take 2 times 6 and set that equal to 3 times 4. So in this case we can see 2 times 6 is 12 and 3 times 4 is 12. So we do in fact know that this proportion is true. 2/3 is equal to 4/6. So in this case we can use the cross products property to solve a proportion. So we have a proportion 9 over 2 equals A over 14. And in order to solve this, we're going to take these two numbers, the 2 and the A, we're going to multiply them together, so 2 times A, and we're going to set that equal to these two numbers multiplied together, 9 times 14. A lot of teachers will tell you to multiply the 9 times 14 and go ahead and have 2A equal to 126. I actually don't prefer that method. I like to have my students leave this as 2 times A equals 9 times 14. I prefer to have my students write this as 2 times A equals 9, which I'm going to list as 3 times 3, times 14, which I'm going to say is 2 times 7. By writing it in this way, I can see that the 2's cancel, and then I have A equals 3 times 3 times 7, which equals 63. Okay, so go ahead and pause the video for a second and try to solve this second proportion. So in this case, again, we use the cross products property. We have 3 times the quantity m plus 1, which is going to equal m times 15. Since on the right-hand side, I noticed that we have m times 15, which I know can be written as 3 times 5 times m, I'm going to go ahead and avoid distributing the 3. I'm going to leave it as 3 times the quantity of m plus 1 because I can get the 3's in this case to cancel. So here I have m plus 1 equals 5 times m. I'll subtract m from both sides to get 1 equals 4 times m. And when I divide by 4, I find that m equals 1/4. Okay, so there are three properties of proportions that are commonly used when dealing with proportions. The first property allows us to take the reciprocal of each ratio. So if we have 2/3 equals 4/6, we're allowed to flip both sides and rewrite that as 3/2 equals 6/4. The second property of proportions allows us to switch the means. So in this case, we start with 2/3 equals 4/6, and by switching the means, we see that it becomes 2/4 equals 3/6, also a true proportion. The third property is probably the least used, but it allows us to take the denominator from each ratio and add it to its numerator. So in this case, we see that if 2/3 equals 4/6, we can write that as 2 plus 3/3 equals 4 plus 6/6. And if we simplify this, we see that 5/3 does in fact equal 10/6. So given the proportion x/6 equals y/7, we want to write an equivalent proportion and justify our answer. In the first case, we have x/6 has been flipped to 6/x. So we should see that that's the first property of proportions. Take the reciprocal of each ratio. So in this case, I would say that this is 7/y. So the addition in this second example seems to indicate that we're using the third property of proportions. However, the third property of proportions says to take the denominator of each ratio and add it to its numerator. So if we were to do that, we should see that we have x plus 6/6 equals y plus 7/7. So there's some problem here because these two things don't match. So this cannot just be the third property of proportions. So we have to start by doing something else. Let's try flipping both of the ratios. So if we get 6/x equals 7/y, which is what we did in the first problem. Now let's take that and step it through the next property of proportions by adding the denominator to the numerator. So here we have 6 plus x over x equals 7 plus y over y. Now, we'll notice that the only difference between this and what we've gotten is that they're in a different order. But since addition is commutative, it would seem to indicate that the answer that we're looking for in this case is we need x in the denominator of this fraction and x plus 6 in the numerator. So the first problem we can justify by simply using property of proportions number 1. Oftentimes you'll see these indicated by Roman numerals. The second problem requires two properties of proportions. We used number 1 to flip the ratios over, and then in addition to that we also used property of proportion number 3 to add the denominator to the numerator. So that concludes section 7.1, Ratios and Proportions. Thanks for your attention, and I'll see you soon.